Okay, in this video I'm going to show you how to use a really low powered laser being powered by a QRP radio and a rectifier, and then actually capturing that laser light in the distance and converting it back to an analog voice signal using a cheap crappy solar panel from an old garden light, which is just plugged straight into the auxiliary input on an amplifier. So I've literally got the garden light onto a the solar panel directly onto a 3.5mm jack plug. Let me see, I can't see what I'm doing here. Oh yeah, where's the aux? I'll turn it around. Oh yeah, aux is here. Alright, so into the auxiliary input. The amplifier's just selected aux. Right. Now I've got this running voice keyer, so it's transmitting automatically. And there you go, see? I'll wait for it to come back.
This is VKE.
I'll just turn up the amplifier. I will show you exactly how to do this. This is rough as guts, but at least it shows you how to do it, right?
1, 2, 3, 4, 5.
Okay, so now I'm going to see which way over in the distance that's pointing. Alright, you might not see, but it's pointing, yeah, see out there on the floor, on the carpet, over in the hallway? So let's get up there, forgive the mess in here, and see how we can harvest the voice from that light up here on the carpet. Alright, so it's back. I'll just plonk the amplifier and the panel down, and I'll capture it properly. There we go.
1, 2, 3, 4, 5.
I'll turn that up full. It is, okay.
This is VK3, VKE, testing on the treatment cycle. Victor Kilo 3, Victor Kilo, testing 2, testing 1, 2, 3, 4, 5.
One sec.
This is VK3, VKE, testing on the treatment cycle. Victor Kilo 3, Victor Kilo Echo, testing 1.
There you go.
Testing 1, 2, 3, 4, 5.
Now the intelligibility is quite impressive. I am quite stunned, so bear with me. I'll just track back and make sure I don't get this laser in my eye. I'll see if I can find it along the way.
3,
oh yeah.
Kilo Echo, testing 1, testing 2, 1, 2, 3, 5.
There you go. Alright, so yeah, and it's very cheap to do as well. Now, of course, there's numerous uses you could use this for. One thing I should point out is it will only work with AM mode, okay? Because, like say, FM mode doesn't really change. It isn't amplitude, so it's not going to change its amplitude with the voice. So the voltage wouldn't really be changing at the rectifier. I'll just stop this TX now. Oh yeah, I should point out where I had the settings. So on this little radio, which is a 10-watt radio, I had it at 1 watt RF power, which is 10% of the max this can do, and my mic gain was at 45%. Now, this is extremely simple. So I've got the tiny little 3-volt, 10 milliwatt laser. You can get like a whole bunch of them really cheap on AliExpress. So really inexpensive. They are focusable. You can actually adjust the end to adjust the focus. But the rectifier is painfully simple. But first of all, this is obviously the source from the radio. So I've got my BNC coming to these alligator clips. I've got my ground side here and the active side here, and a 50 ohm wire wound resistor here just to make the radio happy. Now the reason I was choosing the 80 meter band is because, of course, being a wire wound resistor, this is quite reactive at higher frequencies. If I was at VHF, well, this acts like a significant coil and it would throw it right out. So if you were to use higher frequencies, you would want a film resistor with much less or no reactance. Now, as for the rectifier, is extremely simple. So what we have is 1, 2, 3, 4 Schottky small signal diodes, and these are BAT43, BAT43. So 1, 2, 3, 4, simply 4 in a row. 1, 2, 3, 4, all connected together, all with their direction in the same way. So you can see that one at the far end there, this black band is pointing this way. Got the next one with this black band pointing this way, and this one this way, and this one this way. But a little bit like a transformer, the input we're connecting across 2 of them, right? But the output is the far end, I'll come around this way, of all 4 of them. So we've got the, forgive my bet, see that diode, the negative side of that diode connected to the negative of the laser, and the positive side of this diode to the positive of this laser. So essentially this laser is connected with across 4 diodes in series, but the source is connected across 2 diodes in series, and of course the resistor just to make the radio happy. Now, because it is such a low voltage 3 volt laser, and it's only 10 milliwatt, it actually transmits quite an intelligible signal. Of course, if you adjust your power wrong, you know, if the minimum signal is already at the maximum lumens, you're not going to get intelligibility. So you have to try and get it into that correct range with a combination of your wattage and the mic gain, right? So, but it has to be AM mode. And so that's how simple it is. I don't think you'll need a schematic, but I'll quickly draw one anyway. So here's my very dodgy schematic. So they're BAT43 Schottky diodes. As you can see, we've got 1, 2, 3, 4, all in a string, all in the same direction. Okay, I should have drew that in. And of course, this end is the positive end. Okay. Now, and the other end is the negative end, right? So this is your signal source from the radio. So we have our active and our ground. It truly doesn't matter which way round because it's an AC system at this portion, right? And also across those same 2 points we have a 50 ohm resistor, ideally a film resistor, particularly for higher frequencies. But at the far ends of this string of diodes we have our positive and negative, which is our output voltage source for the laser. So the laser's positive, oops, I can use the wrong color, but the laser positive would be there and negative would be there, and it's that simple. So yeah, just be careful with how you set it up. Don't get the laser in your eyes. And yeah, they're absolutely cheap as chips. You can get them on AliExpress. So a little 3 volt, I think they're 650 nanometer, 10 milliwatt lasers. Absolutely cheap as anything. Now, I did actually do a test where I set up a whole bunch of them, and that also worked just as well, and I had dots all over the walls, and you could pick it up from any dot. So you could convey audio all over the place. You could have little mirrors taking it into other places and so on. But I suppose just for the fun of it, we will do one more run. Let's get that transmitting. Right, so we're transmitting again. I can see the dot way down in the hallway. Let's do it, ladies and gentlemen, and also let me know if you think this is pretty cool. One sec. So I'll just go grab that dot. Oh, it's disappeared, but it will come back. So let's find that dot. I'll just plonk this down. Oh, my dot's moved. Okay. There we go. I'll bring the amp over.
Testing 1, 2, 3, 4, 5.
I'll try to cast a shadow on it. One sec.
This is VK3VB. Frequency cycle. Victor Kilo 3, Victor Kilo Echo. Testing 1, testing 2, Testing 1, 2, 3, 4, 5.
And once more for good luck, because I just think this is so cool for such a simple system.
This is VK3, VKE, testing on this cycle. Victor Kilo 3, Victor Kilo Echo, testing 1, testing 2, testing 1, 2, 3, 4, 5.
Click like, subscribe, 7-3, and yeah, say something in the comments. Hopefully something nice. Cheers for now.